Starter is this. An object is projected upward with a 30-degree launch angle at an initial speed of 60 meters per second. For how many seconds will it be in the air? How far will it travel horizontally? And there's several ways to do this problem. I'll show you one, maybe two ways to do it. So let's take a look at what's given. So I would this problem kind of assumes a horizontal plane, and we're launching an object with a 30-degree launch angle and an initial velocity of 60 meters per second. It's going to have this parabolic kind of trajectory like this, land over here somewhere. And what we want to find is the total time, and we'll call this delta x. The total horizontal distance that it traveled. Now, in your book, sometimes they call that capital R for range. I don't like to do that. I like to limit the number of variables I use and just call it delta x for a complete arc like this. So let's solve it. One of the things to know here, there's a couple of things in problems like this that are not explicitly stated as what's given. And with projectile motion problems, you just have to recognize them. First of all, we know what the acceleration is. The acceleration, and it's in the y direction only, is equal to negative 9.8 meters per second every second. Also, what do we know about the very, very, very top? What is zero? The velocity is zero. Be more specific. The velocity in the y direction, yes, is equal to zero. But we also know that the horizontal velocity is the same throughout the flight. No matter where this object is, just before it hits the ground, the horizontal velocity stays constant because there's nothing to slow the ball down. We are assuming in these problems that air resistance is negligible. We're going to ignore it. And so that makes the problem a lot simpler. And again, when you get to more advanced physics, you will take into account air resistance, especially if you go into aeronautical engineer. It's all about air resistance. But anyway, there's one other thing, and I don't know if I covered this yet, but when you have a problem where it goes up and down to the same level, we know something that will be very helpful to us. We come up and we come down, right? If we just look in the y direction, right? It goes up and comes down. So the level that it leaves the ground is the same level that it hits the ground. So what does that mean? Delta y equals 0 for the entire flight. Now, if you recognize that, if you recognize this, now there's a lot more given information here than we realized, and that really helps. So let's figure out time. And so we need an equation with time in it. And a couple ways to go here. Another thing that we know that's not explicitly given, that if the velocity, if you're going to hit the ground at the same level that you leave the ground, then the velocity in the y direction here, the initial velocity in the y direction, we'll call that v naught y. Well, it's the same velocity over here. This is equal to negative v naught y. And that's because it goes up and down. I mean, you can prove that. So that's another thing you can use. You actually know what the velocity is here, just before it hits the ground. It's 60 meters per second at an angle that is 30 degrees below the horizon. So it's very symmetric kind of a thing. All right, so anyway, we want to know time. I'm going to use the third kinematic equation in the y direction. Delta y equals v naught y times t plus 1/2 a t squared. And I'm going to solve this for time. For the whole flight, I'm going to do it all at once. Because what do I know is true about delta y for the whole flight? 0. And I don't know if you did it this way. What is v naught y? Well, this is 30 and this is the opposite leg, so 60 meters per second times the sine of 30 degrees is, I mean, that you can do in your head, it's half of 60, right? The sine of 30 is 0.5 times 60 is 30 meters per second. So we know what this is. But we can solve for time in just a second. So this is 0. We know what this is. We can know what this is, so we can just solve for time. So I'm going to go 1/2 a t squared is equal to, put this on the other side, negative v naught t. And then I'm going to multiply by 2. And I'm going to cancel out one of the times. By the way, what does this mean? If delta y here, one of the solutions is t equals 0. At t equals 0, delta y is 0. Right? I mean, this is a quadratic formula with t in it, and one of the solutions is t equals 0. Pretty trivial answer, though. If you give me that, that'll be wrong. But it is true, but it's also the wrong answer. But now we can cancel out this and solve for t. So I can divide by a. So t is equal to negative 2 v naught over a. So let's plug in the values. And then v naught is, this is v naught in the y direction. I should specify that. Well, just to save a little time, I'm going to say it's v naught times the sine of 30 degrees, multiply that by 60, you get 30. So this is going to be 30 meters per second. And what is my acceleration? Negative 9.8 meters per second squared. And so what do you get? That's going to be 60 divided by 9.8. It's going to be a little over 6 seconds. What is it? 6.12 seconds. And there's my answer. Okay? And then, now to find delta x, once you know the time, the rest of it's pretty trivial. Delta x equals v naught x times t. V naught x is 60 meters per second times the cosine of 30 degrees, right? That's the horizontal component of my initial velocity, times a time of 6.12 seconds. And so if, it's about 30 meters. What'd you guys get? Oh, wait, I'm sorry, 300 meters. 300 meters. What is it? 318? Okay. Now, how did I get 300? I just gave, okay, this is about 0.8 of this, so that's about 50. I called it 5, that's why I guess 30, but 5. Or 50. 50 times 6 is about 300. So, and it's an excellent habit for you to do a little mental arithmetic to get, what the answer should be close to before you actually compute it, or after you compute it, to make sure that you didn't do a calculator mistake. And not that important in the world of school, but it's very important in the world of work. In the world of school, there's usually a textbook or a teacher that's going to give you, you can check your answer with, or, they're going to grade it and give you partial credit or something. You guys, if you're designing a bridge and you are off by an order of magnitude, the teacher's not going to give you partial credit. All right, you're going to lose your job. Okay, that is all.